Okay, hello everybody. Welcome to our webinar where we will talk about Bentley system solution, and this time we will talk about OpenBridge Designer and AdriaBIM. So a lot of information about bridge modeling. My name is Primož Skubic. I'm coming from company ADST. I'm a senior key account manager responsible for also Bentley solutions. I must mention that a lot of you are with us in this kind of journey because we are presenting the solutions or softwares from Civil Work Suite, which has 9 different solutions under this suite. And we are going so from the beginning to the end. And today we are on the bridges. So with me is also Jean-Pierre Chanard from Bentley Systems. And I will put the introduction and everything to him and also the presentation. So welcome to listen us and enjoy on the webinar. Thank you.
Hello, I'm Jean-Pierre Chanard, so I'm from Bentley and I'm a civil engineer. I started working with bridges, then joined Bentley for civil 26 years ago, taking care of civil in global. And when we acquired the bridge software in 2008, I only take care from that time on bridge design and modeling. And this is the subject of what I will show you today. So bridge information modeling with OpenBridge Designer. Okay, so OpenBridge Designer is part of the Civil Work Suite where we gather different things. So to model and design railway, road, site, bridge, tunnel, and all the civil around this. Okay, so if we look at the bridge workflow today, what we find in many companies, so using different software. So we start anyway from the roadway geometry. Then people use sometimes some parameterization software, creating some models. From that models, they create what we call a physical model, okay? And from that, through an exchange format, they go to different things for analytics, for instance, or constructability reviews, or finally, plan design. Okay, so what we try is to change this to a different workflow where everything in the same software, and we all start with the 3D physical modeling. So this will be using OBM, we'll see. In an automatic process, we can send data and transform them into analytical data and send back some results also to the 3D physical modeling in order to update our model to take into account the result from the design. At the same time, from this 3D physical model, we generate all the design documentation. That means 2D plans, quantities, all that kind of things. And what you need to understand is all that is at the same time. So that means that even if we have already generated some design documentation, we can still update the analytical model and update the physical model. In that case, the documents will be updated automatically. And at the end of this process, through still an automatic process, we can send the data for construction and also asset management. In terms of software, what do we have? We have different pieces of software. So some were existing already at Bentley, some were totally created from scratch, and finally, we put them all in one software. So the first thing is everything rests on what we call Bentley Civil. So what is Bentley Civil? Bentley Civil is mainly an object-based platform that will handle all the civil objects that we need. And we need some of these objects in all the different software, like, for instance, the geometry and the terrain. And on this Bentley Civil platform, we have open roads, open rail, open site, open bridge, open tunnel. That means that because they share the same base, all this software can read and write the same files. These files have a footprint of the software that they were that was used to generate them, so not to have the ability that with a road software you modify a bridge software, but simply by putting these files in reference, we can directly use all the data from open roads, for instance, to create a bridge. And you know that when we create a bridge, anyway, usually there is a road upon it, or there is a road under it, or there is a rail and all that kind of thing. So everything is linked. Okay, so this OpenBridge modeler, which is an intelligent parametric 3D modeling for the bridge, was totally built on this platform. And we created interface inside the software to two different analytical software. So LibBridge, we will be very quick on this one because it's only take care of small and medium bridges, very easy way, but only take into account the American standards, and OpenBridge that I will show you, which is our general bridge solution, so analytic bridge solution. And from that, we can directly feed all the software and take back some of the data. And finally, we had also other software in-house that were called Substructure. Substructure is a detailing software that is used both for concrete and steel. And in the first step, we made a full interface between the OpenBridge model and the Substructure, ProConcrete, excuse me. And finally, we decided to put on the market only one package, which is OpenBridge Designer. Okay, OpenBridge Designer has, at the same time, the modeling software and the analytic software. We have also the possibility to have only OpenBridge model. It's just for a price, because usually there is twice or three times the people modeling than analyzing the bridge. So just to be in phase with these numbers. And when you have OpenBridge Designer, we will see in OpenBridge Designer there is inside a direct interface with ProConcrete, and ProConcrete is delivered also in OpenBridge Designer. Okay, this is, excuse me. This is the interface of OpenBridge Designer. So OpenBridge Designer is a nutshell containing the different access to different software, and that will take care about the workflow between the different model, between the physical model, the analytical model, the drawings, and eventually the interoperation. And assuring that it's a perfect BIM exchange if we want strictly a BIM exchange. So that means that modeling can be only done with modeling software. I mean, OpenBridge Modeler, analysis only with analysis, and you cannot directly go to analysis. We have also a standalone workflow that allows all the users to go directly to each part of the software. And so this is the different analytical software: LibBridge, Steel, Concrete, and OpenBridge. Okay. If we go to OpenBridge Modeler, which is the heart of the OpenBridge Designer, we support, you know, there's a lot of bridge types. So we could not, from the beginning, support all the bridge types. So we try to support the most used bridge types. So that means pretension concrete guided slab, steel guiders and concrete slab, segmental bridges, cast in place, and concrete box. Okay. Also, this is for mainly the upper part of the bridge, but also we have the possibility to place all the substructure, meaning by that abutments and piers. Sorry for that. We will see that we have two different kinds of substructure, what we call standard substructures. So standard substructures are I would say some parametric object where all the parameters are embedded in that object. So you can change the values of these parameters, but you cannot add new parameters. And we have also custom object, both for abutment and piers, where we can design everything we need. Okay. So these are the kind of piers, for instance, that we can create with standard object. And you see that already we can create very complex piers like that, because more and more we add possibilities into this pier, like defining our own cross-section for the columns and defining different variations for that. But clothing the user inside a parametric object, after there's always thing that he wants more possibilities to do. That's why we have developed what we call the component, so parametric component. And this is the type of, for instance, abutment that we can directly create inside OpenBridge modeler. So you just define your own list of parameters, and when you place it, after you can have access to all these parameters. Also, some parameters are updated directly by the software, like the top slope, for instance, or the width of this abutment. But you see, this can be quite complex. And here, let's see, when we place this, we can just clicking in the file on the object, we have access to all the different parameters, and we can put in place the abutment as we want. And this object will be also fully listed in the list of materials, okay, quantities. Okay, here you see we can act on each parameters inside the file. Okay, otherwise, when we use standard bridges, so everything starts from an alignment. And based on this alignment, we can add a bridge. Then we define the number of spans and so the number of supports. Then on this bridge, or on this geometry, excuse me, we can define a cross section of the deck. Here we have a parametric deck cross section. This can be fully designed by the user or picked inside library. We apply this profile along the alignment. Then here we will define a beam layout. So we define where we place the beam, and we can have even so different possibilities. So we can have a unique beam all along the bridge, or we can have beams, straight beams, span by span. So we can define that here we will have precast beams. So it will be straight beams, and they are placed under that after we place the different supports. And all this is linked together. So you see, we do that in the out order because the piers and the support depends from the deck elevation, but the placement of the different support depends where we have placed them along the alignment. And I can automatically, when I select a support, place all the support at the same time. But For each of them, they will be adjusted automatically to the distance between the ground and the deck. So adjusting the column height. And after, we can also place bearings. The bearings can be represented either by a concrete cube, which happens often on that type of bridge, or we can place cells and we deliver different cells representing the bearings, real bearings that we will have also in quantities. And everything, when we place bearing, the height of the support is automatically adjusted. The same for the abutment. The back wall will be adjusted so that we have the correct height of the back wall, and also the top of the back wall is adjusted to the full geometry of the deck. And we can place also many details like barriers or signs or lamps or everything like that. Okay, we have the same possibility, but for steel bridges. So I mean concrete slab with steel beams. So in that case, we take, for instance, a circular alignment. We place in the same way, we place the deck. That can be also this variable, so we could have it widening or changing slope along the bridge. We can even directly read, for instance, the super elevation from the road to apply it to the bridge. Then we define the layout of the beams that we will place under the excuse me, under the bridge. In the same way, we can place either a continuous beam all along the bridge, or we can place beams span by span. The cross-section of the beams can be of two different ways. Either we can pick standard profile beams, or like in this case, we just define the different parameters as the parameters of the flanges and the parameters of the web. And also we can have variation along this. And for the steel, we can do also the same for concrete, but in Europe, we put less steel cross frames. But we can define different types of cross frames and place these cross frames along the bridge at different positions. Okay, we can also place stiffeners, different stiffeners, for instance, on the support, on different side of the web. And so here you see these cross frames that we have placed between the beams. So here we have more better view of what we can place when we remove the different elements, or we see it in transparencies. And you see, this is the type of level that we have on the cross frames. OpenBridge Modeler is not a detailing software. As I said, we are after using other detailing software, which is ProConcrete and ProSteel. And for ProConcrete, we have finished the full interface, and we are working now on the direct interface between OpenBridge Modeler and ProSteel. So we will be able to detail all that kind of connections, but already all the geometry and the quantities are okay. Another kind of bridges is segmental bridges. So in case of segmental bridges, so usually it's box guiders, okay? And we have two different types of segmental bridges. So we can have balanced cantilever, or we have span by span segmental bridges. So we can define which we want to place, and in that case, we can have a lot of different parameters. We can, for instance, define, here it's span by span, so we can define what is the value between the segments on each pier, okay? So usually this is made in straight, excuse me, in straight span and maybe for subway. In case of balanced cantilever also, and in curved bridge, what is interesting is that we can define exactly the position of the cross-section. It can be coded if we have precast segment, for instance, or it can be perpendicular to the alignment. The joint also can be perpendicular to the vertical alignment or vertical directly. So we can choose really and go to precise geometry, because the aim of all that is to have a fully very accurate model of the software, so we can after have exact quantity for each segment, but also to have precisely the layout of the different segments. But I was talking, so the different reports that we can generate, and quantities is only one of these reports, but it's very useful and it can be used at any time. So it means that you can directly check your quantities at any time of your modeling time, so to see the differences between if you use that type of bridge or another type of bridge. But also, standing to the construction site, we can perform many different geometrical reports, like a deck elevation, beam seat elevation, pier elevation, support elevation. So all these data which are needed on site to correctly build the bridge. Okay, so this is an example how we can very easily generate the different data in a report. This report can be saved in different formats. So it can be saved in directly PDF, but also you can save them into Excel sheets, so you can rework after the format of the report if you need it. And all this report we can regenerate. As you see, it's very quick, so they are not regenerated automatically, but it's just pressing a button and you can regenerate them if you have made some changes. Okay, now let's see the integration that we have. We have seen how to model different bridge, and let's see the integration with RM bridge. So here, wait, it's not the... Okay, here is creation of a balanced cantilever bridge. So I use this type of cross-section, which is fully parametric. Okay, so here you see when I change some parameters, my cross-section is updating, following the rules I asked. So for instance, to have the same slope. And here in this balanced cantilever bridge, I will place it cantilever by cantilever, so it's not span by span, it's just piece by pieces. I will start from the beginning of my bridge, defining the size of each segment, maybe a different size for the segment on abutment or segment on pier, and even I can divide the segment on pier into two parts. This is mainly what we do on site, because you have usually heavy diaphragms on the piers, so you need sometimes to cut in two pieces, otherwise you cannot carry it on top of the pier. So we define all this here. At the same time, we define, as I said, if we have the orientation of the cross-section. Coded means precast segment. So in a precast segment, in the casting cell, you know that the side of the segment are perpendicular to the face of the segment. So it's not exactly perpendicular to the curved alignment. Okay, it's just the side of the segment are straight and not curved. That's why we have a slightly different geometry, but which is very important when we create a report. So we do it like it span by span, okay? And the software at the same time also check that there is no overlapping of segments. And also we can limit the side the size of the break between two cantilevers. So finishing here. Okay, and at the end, I just check and put the closure. So here you see I have a space between the two parts, and I will put the closure, defining the maximum closure, and my bridge is checked. And what is interesting, I can after generate variation along that bridge. Okay, so using the different parameters that I have defined into my on my box, I can define the way these parameters will vary along my bridge. So finally, I can have a realistic bridge, so with different variations. I can use directly copy paste from Excel sheet, so that will helps me a lot to create this different variation. And also when we have complex variation with maybe 30 different spans, where usually you recopy from span to span the different variation, Excel is very useful for that. And you see when I apply it, here you have a dynamic cut, so you can see what happens, changing the size on the pier and also tilting the this. Okay. What is interesting now is when we have finished this bridge, how do we export it to RM? And this is the big advantage of the software. We have all created the software. The only thing we need to do is to choose which software we will use. Okay, LIP or RM. Here I will use RM Bridge. It collects the data. I need some more data, which is mainly the accuracy. So in how many pieces I will cut my deck and the different supports. So for the deck, I will use one element per segment. And also for the support, I need to specify if I'm free or fixed, or if I have more precision, I can define directly the real stiffness of the bearings. And at that time, the software will export and opening RM Bridge. So you see the interface of RM Bridge, and created, it's a new model because we don't have the same internal format. Okay, here we deal with finite elements and nodes. Otherwise, we were dealing with solid modeling, but the link is fully automatic. And also this creation of analytic model is done intelligently. That means that it will be different if we have BIM bridges. In that case, each beam will be represented, or if we have a box guider where we have a finite element model of the cross-section that is displayed, but which is exactly the same. And we have also the same variation, and we find exactly the same geometry. And here the same visualization of the bridge that we had inside the OpenBridge modeler. Okay. Then in this model, I can define different load case. Some load case can be automatically created because the software, for instance, knows the weight. So here I will create my weight load case. And what is interesting here when I see it, you know that usually we have all the elements are numbered, but we have the software has created automatically assemblies, so you can load Pier 1, Pier 2, deck. You can also directly and on the visualization define the different elements you have created. We see that in the schedule we have already steps that are being created. We will see that later. I will just create a new one and asking to compute the load case. So this is just what I ask, and I will run. So as you see, I do not change anything in the model. I don't modify anything, just running. And as soon as I run, I can get results. So I can see also this result on my model, or I can generate different reports in PDF, in Excel sheet, and all that kind of things. But also I can simply have diagrams representing the result. So in that case, for instance, directly on my bridge, I will display the displacement, exaggerated for sure, because otherwise I cannot see them on my screen. And I have a diagram, for instance, on the bending moment, so I can follow exactly what happens. As I said, the schedule was defined also in OpenBridge Modeler, and this schedule is automatically transferred into OpenBridge. So to be sure to have, this is one main principle of the BIM, is that when you enter one type of data, you don't have to re-enter twice. So to avoid making mistakes. So automatically, this is what is transferred, and you see step by step during the construction, this is the way my bridge is built, and taking into account just the data that I have defined inside OBM. Let's review OpenBridge and the possibilities of OpenBridge. So OpenBridge is a very general software. It can be used for any type of bridge. When I was talking about OpenBridge Modeler, I said that we restrain maybe with, because with OpenBridge Modeler, for instance, we cannot use it fully, at least for cable stay bridge, for arch bridge, or things like that, because it's a little more complex. We can use for the base, but not for this. In the case of OpenBridge, we can model any type of bridge. Whatever the material is used, whatever also the type of structure we use, but also because OpenBridge is used to study the bridge during the construction, we have different wizards helping you to define the process to build the bridge using span by span or adventuring, incremental launching, balanced cantilever, all that kind of things. And what is important also, it's internationally applicable. So we cover for sure the Eurocode, but also different codes in different countries. And because we support these many different international codes, the software is very open, so you can also act on the software itself to custom it if you need specific things into the code that you have to define. Okay, we can do general analysis, okay, and we can do also specific analysis. So taking into account, for instance, P delta, cable sagging, so all that kind of specific things that often applies to large bridges. Okay. The principle of OpenBridge, and that's why also making an interface with OBM was not so difficult, is because from the start in OpenBridge, we had this notion of double model. One, what we call a geometrical model, and another one we were calling analytical model. The advantage of the geometrical model is that first, you handle bridge characteristic, so piers, decks, variations, things like that. And all this model, the different parts are linked. The piers are linked to the deck. The deck is linked to the geometry, exactly like we have in OpenBridge Modeler. And from that, we export to analysis. So step by step, we replace the modeler for OpenBridge by OpenBridge Modeler. But we keep OpenBridge Modeler because as we can see, we can, so here we have a direct transfer, but we can have also different wizards for automatically creating small and medium bridges very easily, and automatically generate all the different load case, and the same generate at the end all the different reports. So it's a kind of push button software where for small and medium bridges, in sometimes you can create this. And we have OpenBridge Modeler where we can cover all that kind of type of bridges. So many different, like complex like truss bridges, that kind of bridge, for instance, today cannot be covered with OpenBridge Modeler. It's much too complex for this. Okay, in this software, the cross-section properties, so we have a two-step analysis. The cross-section by itself uses a 2D mesh of finite elements. So we can take into account local stresses, okay? We can have also composite section. So that means that we can activate different parts of the bridge during the construction, but we can also activate different parts of the cross-section itself with different materials, which is very interesting in that kind of cross-section, which is concrete and concrete, is that we have usually a pre-stress beam here that will support the traction, and we pour concrete once this is built. So that means that our deck will be mainly compressed. And in that case, RM will handle both modelization at the same time. So we can have the forces globally in the cross-section, but also it will be able to define for each part what are the different forces that you have. For instance, in that type of bridge composite, due to weight, for instance, you will have heavy compression at the heavy tension, excuse me, at the middle of the span in that part, and heavy compression here, all that kind of things. Okay, we can use also other finite elements. So mainly in bridge, you know, we usually use beams. Simply, first, it's easier, I think, to understand what happens. But also, if you look at the codes from different countries, we always refers to result from beams. But we can use also a mix of a plates element. And in that case, the software will automatically transfer the beams to the different plates. So making this very easily to handle. And also we can have a mix of them. So typically for that kind of bridge, we saw with the concrete deck and steel frames under it, we have the steel frames represented in beams and the deck in plates. Okay. For the analysis, we have different things. So around the schedule where we can activate different parts and we can do anything at any steps. As I said, we have international code where we support and we deliver all this code with all the materials. Also with the live loads definition, which is an important part. All the load case combinations, all the code checks around the code, even some design against code. Okay, we can design also steel with the different category of steels. For the loads, we can have static loads and dynamic loads. For pre-stressing, we use internal tendons, external tendons. Internal tendons can be pre-tension, post-tension, so external tendons also. And for all of them, it takes into account all the different characteristics and also the schedule of tensioning this. For the analysis, we have static elastic, dynamic elastic, static nonlinear, and dynamic nonlinear also. Construction phases where we can activate step by step. In dynamics, we can have either eigenvalues, but mainly response spectrum analysis, other model analysis, or also time history analysis. And we have a lot of wind analysis, and we have a CFD inside the software itself. Rolling stock analysis, where we can also find out what is the worst train at worst speed running through a speed very quickly. This is very interesting to check. You know that often the span, when the span is short, we have a lot of reaction and not always at the highest speed. Here's the difference between a static and dynamic reaction. We have also seismic design analysis, okay, with different ways, equivalent static or by response spectrum, and you can define. So standard spectrum are delivered with the code, but you can create your own spectrum also. And also we have non-linear time history analysis or linear time history analysis. And the same, we deliver some accelerogram, so typical the ones that we use, but you can also generate random accelerogram when you give the standard spectrum and the software will generate this. We have specific elements for this analysis, okay? We can also use displacement-based design. So compare the capacity with the demand. This is very useful, very quick. It's a nonlinear analysis and give very quick answer compare with step-by-step analysis. Okay. One big advantage is what happens if we modify the bridge. And if we modify the bridge, you see that, for instance, I changed the geometry of the bridge, and automatically everything is updated in my OpenBridge file. All the different drawings will be also updated, but if I resend the data to AdriaBIM, not the software will not rebuild a new model of the bridge, but it will just send the modification because we use XML files. So we enter exactly the same file, but the geometry in that case is updated. If we have changed the cross-section should have been changed during this process, or if we change different types from the support the same way. But all the rest, here we can see that we have a different geometry, for instance, that has been updated, okay? But all the rest is not modified. That means that after sending, we can directly send the calculation without redefining the root case, because everything was stored in our model. It's just a model that we update. So we resend the calculation, and after this calculation, we just display the result, and we can compare the result with the previous result. So you can make differences between your model before the transformation and after the modification. And in that case, we can display, and very easily we can do that. And you see mainly the difference. We can display also previous results at the same time. Okay, we can generate drawing. So the most interesting drawing, we use a standard microstation to define drawings, but I will just accelerate a little. Along the profile, we can ask just intersect, okay, the bridge with the profile. So here we have a detailed result for the intersection, but more than this, we can reproject the back part of the bridge on top of this intersection. So we really create a profile drawing, which is usually impossible inside microstation, because it's not a flat plane we are cutting through. Okay, and here we will see, if I ask to update my view, I will see now the different details of my bridge. Okay, you see the bearings and all this appearing, and the different parts inside the deck. Okay, for concrete structure, I said that we can directly add rebar. So this can be done directly inside OpenBridge model, or if you are using OpenBridge Designer, you can use ProConcrete as it is shown here. So we just place the different bars. The main difference in OpenBridge Modeler only, you cannot generate all the annotation. In ProConcrete, like it is here, you can generate at the same time the drawing, and you see that when we extract the views, there is a resymbolization that is done. So it looks like a standard reinforcement drawing, and not like a geometrical cut of all the different cylinders. Okay. And what is interesting is that if I make any modification also on my model, so here I have the reinforcement of a pier. You see I have 3 columns of that pier. If in AdriaBIM I modify the different values of the my piers, so I will change here the size of the footing and the size of the column. I will accelerate. Once I go back now to my reinforcement, my concrete is reference to my drawing. So I just ask to update my drawing, and look what happens here. Automatically, the bars are updated. In this view, this is a resymbolization. So I just need to ask by putting a data to recompute the resymbolization, and all the annotations are updated, and my drawing is updated. Just to understand that using OpenBridge Designer, you just make once the model, and you generate all the detailing, you generate the analysis. But once you make modification, everything can be updated very quickly. Some are updated automatically. Some you just need to resend calculations, or you just need to ask an updating of the different drawings, and they will be updated. So these are the different things that you can generate inside rebars, quantities, and so on. Okay, I finished the presentation, so I try to accelerate at the end so you can ask some questions. Here you had a global view. After we can enter in more detail, but I'm sure that you have different questions, and I will try to answer them.
Sure. Okay. Thank you, Jean-Pierre, for a very nice presentation with a lot of information about OpenBridge Designer, Modeler, and AdriaBIM. And yes, we have a question already, which is the first thing. It was that the lady who is the head of railway substructure office, she's asking, is it possible to calculate the reliability of the bridge?
It's possible to calculate. There's no problem. The problem is now is what part exactly. There's different part in this. First, you can usually we can check what are the possibility of a bridge when you observe that there are some defect in it. So you can degrade. I will try to say the performance of the bridge. You can do that. And in RM, we have many different ways to take into account the fact that your concrete is not in good shape, or the steel also is not the section that you expect. So you can automatically multiply the different characteristics by a minoring value. This is one part. The second thing is when you rehabilitate a bridge, often we add another part of the bridge. In the cross-section, we enhance the cross-section with new elements, maybe with steel elements, with press stress. And this we can handle because we perfectly handle composite cross-sections. So a new cross-section, which is done, which is an assembly from an old cross-section, and a new part that we have handled. And you can also get the different force that you have between the old part and the new part. So yes, we can handle. I will say that the biggest difficulty here is to estimate what you have to do. So this will be your job and not the job of RM.
Okay. And another question is it compatible with BIM? I think that we also mentioned this.
Yes, it's compatible with BIM because you have seen that mainly when we make a change. So I explained in OpenBridge Designer, we can have a pure BIM workflow. In that case, all the modelization will be done inside OBM to be sure that when you make a modification inside OBM, you can transfer it into RM, and you are not allowed to do a simple modification in RM. Otherwise, you disconnect the BIM model, analytical model, from the physical model. After, you can, sometimes it's interesting to allow some transformations. It depends after what you want exactly to have.
Okay, great. And another question, is it possible to calculate bridges with high hysteresis dampers?
Yes. Yes, yes, yes. So we have, I was quick on that, on the dampers, but we have different dampers that we can use. So we have mathematical, what we call mathematical dampers, where finally you define manually, I should say, by curves, the relation between the force and the displacement. We can also define hysteresis behavior. Or also what we have inside RM, you can directly, we have a catalog of standard dampers so it's mainly isolators that we use. So lead bearings, or also, I don't remember the name in English. It's where it's, should find if I have it. I will show you directly. It's simpler. Okay. Friction pendulum. Yes, that kind of dampers. Okay, where you can define. So we just have a catalog of them, and you can just place this friction pendulum, and automatically it puts the good parameters on a standard bilinear hysteretic element that we have inside the software. Other question?
Okay, great. Let me check. Okay. Okay, if there is any kind of question, please put it in the chat and we will answer it on it. Maybe one question, Jean-Pierre, from my side. Yesterday, I was on the site with the user of AdriaBIM and OpenBridge Designer and Modeler, and he was just asking me, maybe you know directly, were from the past to now any kind of changes, because he was asking that he remembered that in the past you can open more than one project in the software, but that these days is not available. It's some kind of change, or?
No, I don't know what you mean by open more than one project.
So
Well,
they are doing in a few projects,
yes,
and in the past they said that I don't know, they could have open 2 or 3 projects in the same time.
yes, we can. It's this is just a question of usually it's a license program. Anyway, the software, you can open it. You can open it how many instances of the software that you want. After it will take memory for sure. That's all. But after, as soon as you have different project open on the same station, this is using only one license. So you can perform. This is sometimes interesting. For instance, to have one project, you send the calculation, so which is done in the background, and you can work on another project at the same time. It's not a problem. Yes.
Okay. Okay. Then just we need to show them how to
Yes.
do it.
Yes.
Yeah.
The,
Yeah. Yeah.
the, the only change is when we were using RM, it was very easy to do. When we go to OBD, we have to go back to OBD at the same time to open another project in OBD. That's the main difference, and maybe a little more complex. That's what they were using before. But there is different way to do it. Yeah.
Okay, great. Let me see the questions. Okay. Yes. Okay. The lady said thank you for the answer. I think that we that we go through the whole topic. If there will be something, yeah, we are also available. Also, Jean-Pierre is available. And he can answer the questions. I don't know, later when you can
Because
send us
yes,
on
by
the
mail, no problem.
email or something like that.
Yeah.
I just want to put one information because it's important. This week, also Bentley Systems, through the Virtuosity, they are celebrating the engineering week. So that means that they are giving promotion 20% on the all Bentley products, which are in the e-store of Virtuosity. So it's easy to order. We can help you also as a channel partner of Bentley Systems. So yes, you are welcome. This is this week, and you have only 2 days left. So just to do a little bit promotion also from my side. Look, Jean-Pierre, I will say thank you for your really good presentation about OpenBridge and AdriaBIM modification, all these connections between one and another software.
Okay.
Yes, you are welcome to join in the next webinars, which we will do it quite quick in the next months, or if I can say next weeks.
Okay.
Okay. Thank
Thank you
you,
very much
Jean-Pierre.
to all. Thank
Okay.
you. Bye.
Thank you. Bye-bye, all of you. Thank you.